Okay, so what we have here is an application of the square root property. And the reason why that occurs here in this investment problem is because we're going to go ahead and work this problem out to find the interest rate to take money from $500 to $590 in an investment. We don't know the interest rate. That's what we're going to solve for. But we do know the time is 2 years. So we're going to end up with an exponential kind of situation. It'll be a square, and therefore we're going to solve for r through the square root property. So it's an application of the square root property. And we're going to go ahead and fill in the formula. This is an interest growth rate problem, and so we have a interest growth formula here. And the way it works is P is the initial investment. That's the $500. A is the amount of money at the end of the investment. That's the $590. And then we have the R in the parentheses that we need to solve for, the rate of interest, to have that grow from 500 to 590. And we're putting a 2 for the 2-year period in which we want this to occur. All right, so let's see what we can do. Well, if you watched the last video or you've worked some of the problems from class, you know when it comes to the square root property, we need to isolate the square first. We're going to divide by 500. So I'll go ahead and work that on my calculator here. Let's see, we got 590 divided by 500. And it turns out to be 1.18. 1.18. So I'm going to go ahead and have my square of 1 plus r equal to 1.18. Now I'm going to take the square root. Now that this square is isolated, and that will turn into 1 plus r is equal to plus or minus the square root of 1.18. Then I'm going to subtract 1. I don't make it part of the plus minus, so I don't want it over here. I'm putting it in front, and I have negative 1 plus or minus the square root of 1.18 is equal to r. And if this was a theoretical problem, I would just leave the answer like this, and say that that's the exact answer. But it doesn't make much sense for this practical problem, where I'm actually trying to find an interest rate. So let's go up here and boil this down a little bit more and see if we could get an actual rate of interest. So what we're going to do is, first of all, break this up into the two answers represented there, and they are negative 1 plus the square root of 1.18 and negative 1 minus the square root of 1.18. Well, it turns out that I'm going to let this answer go, because a negative minus even more is going to be a negative answer, and that is an answer theoretically that works in this equation, but it makes no practical sense in an investment that's gaining money. And there's no way I could use a negative interest rate to get there. So I'm going to cross this off. And let's just focus here, which means I'm going to have to take my calculator and get the square root of 1.18. So let's do that. So on this calculator, my square root button is right here, so that means I have to hit second and then x squared to get to the square root feature. So let's do that. And so I'm going to get here, let me clear this again. I'm going to hit second, and x squared actually gives me the square root feature, and then I'm going to put 1.18 in there, close the parentheses, and I get a decimal that, remember, this is an irrational number. It goes on forever without any repeating pattern. So I'm just going to round off here to 1.086 on my paper. Okay, and when I add these together, I'll just get 0.086. But that as an interest rate is 8.6%, and that would be what I would have to earn per year for 2 years on $500 compounded annually. In other words, I would get to add my interest onto my original investment of $500 at the end of the first year, and then earn another 8.6%. And when that was all done, at the end of the second year, I'd have $90 more than when I started.